There is a question so old we carved it into temple walls before we ever wrote an equation. And there is a science so new it can predict the behavior of atoms to 12 decimal places. For most of history, the two had nothing to say to each other. Until now. Because a century ago, physics uncovered something it has never fully recovered from. Not a new particle, not a new force. Something far more unsettling. A crack in our picture of reality itself. For hundreds of years, physics painted a simple picture. A universe that existed whether anyone was there to witness it. Stars ignited in silence. Galaxies collided in darkness. Atoms combined and separated without a single observer. Then, physicists looked deeper, far deeper, past molecules, past atoms, into the strange quantum world where certainty dissolves and reality begins to behave in ways that still defy explanation. Matter seems to hold its breath. It refuses to commit. It exists as a whisper of possibilities until something we call a measurement takes place. And in that instant, the universe seems to make a choice. Physicists have argued about what this means for a century. Some of the greatest minds who ever lived, the very people who built quantum mechanics, could not agree on what they had discovered. Even today, there is no single interpretation of quantum mechanics that every physicist agrees upon. Some said it was nothing mysterious at all. Others privately wondered if they had stumbled onto the deepest secret in existence. Because if reality only becomes definite when it is measured, then who or what has been there to measure the universe for 13.8 billion years? Before the first eye ever opened, before the first cell was divided, before the first star burned. Was anything there at all? Tonight, we follow this question as far as it can go, through laboratories and equations, through the birth of the cosmos, through the nature of the mind itself, and finally, to the edge of an idea that science cannot confirm, cannot deny, and cannot quite escape. An idea whispered in temples and cathedrals for thousands of years, now returning through the back door of physics. To understand how physics ended up asking a question it thought it had buried, we have to go back to the single most quietly disturbing thing ever seen in a laboratory. Not an explosion, not a collision. Something gentle. Something that at first glance looks like nothing at all. Take a wall with two thin parallel openings. Send waves toward it and something familiar happens. The waves pass through both slits at once, spread out on the far side, and overlap. Where two crests meet, they add together and grow taller. Where a crest meets a trough, they cancel and flatten to nothing. On a screen behind the wall, this leaves a signature no one can mistake. A series of bright bands and dark bands alternating across the surface. Physicists call it an interference pattern. It is the unmistakable fingerprint of a wave. Water does it. Sound does it. And light, we learned long ago, does it too. We learned it at the dawn of the 19th century, when a physician and polymath named Thomas Young first sent light through a pair of narrow openings and watched those bands appear on the far wall. It was a small experiment with an enormous consequence. For over a century afterward, the matter seemed closed. Light was a wave. Matter was made of solid little particles, and the two categories were as separate as fire and stone. This was the physics of the 1800s, calm, ordered, and confident. A universe of billiard balls and ripples, each obeying laws you could hold in your hand. Nothing about it hinted at what was coming. The strangeness begins only when we make the experiment smaller. Much smaller. Instead of a continuous beam, imagine we could fire the light one tiny piece at a time. A single particle. Then another. Then another. We can do this now, not just with light, but with electrons, the very particles that make up the outer shells of every atom in your body. We can release them one by one, so slowly that only a single electron is ever crossing the apparatus at any given moment. There is nothing for it to bump into, nothing for it to interfere with. It travels alone. Each electron strikes the screen and leaves a single tiny dot. One particle, one point of impact. Exactly what you'd expect from something small and solid. But then we let the experiment run. 100 electrons, 1,000, 1,000,000 dots, each one arriving alone, each one seemingly random. And slowly, out of that storm of individual points, a pattern emerges. Bright bands, dark bands. The interference pattern returns. When results like these first began to surface, physicists did not celebrate. They recoiled. Many were convinced something had gone wrong with the equipment, that a stray vibration or a flaw in the apparatus was manufacturing a pattern out of noise. It had to be an error. Particles were particles. The idea that a single, indivisible speck of matter could spread out and interfere with itself was not merely surprising, it seemed to violate common sense at its foundation. And yet, the checking only made it worse. The result refused to go away. So they tested it again and again for decades with ever more care and ever stranger materials. Electrons produced the pattern. Then photons, fired one lonely packet of light at a time, did the same. Then whole atoms, objects thousands of times heavier. And then, most astonishing of all, large molecules, intricate clusters made of hundreds and eventually thousands of atoms, structures almost on the edge of what a microscope can see. Each of them, sent through the apparatus alone, built up the same unmistakable bands. The effect was not a quirk of the electron, it was a property of matter itself. Sit with how strange that is. Each object traveled by itself, with nothing else around to interfere with. And yet, collectively, they arranged themselves as though every single one had somehow passed through both slits at once and interfered with itself. A lone particle behaving like a spread-out wave. As if, on its way across, it stopped being a definite object with a definite location and became instead a range of possibilities, exploring every path at the same time. This is what physicists mean when they say matter is described by a wave. Not a wave in water or air, but a wave of probability. Before it lands, the electron doesn't have one position. It has a spread of potential positions, each with its own likelihood, all coexisting. The mathematics that captures this is called the wave function, and it forced physics to abandon something it had never questioned: the certainty that every object at every moment simply has a location. In the old picture, If you knew enough, you could predict exactly where anything would go. The wave function shattered that promise. It does not tell you where a single electron will land. It refuses to. It offers only the odds, and here is the part that should stop you cold. Those odds are perfect. For the better part of a century, the wave function has been the most successful predictive tool humanity has ever built. Tested to a precision so extreme, it is like measuring the distance across a continent and being wrong by less than the width of a hair. Every transistor, every laser, every device you have ever touched runs on its accuracy. Nothing in the history of science has been confirmed more thoroughly. The theory works. It simply refuses to tell us what it means. Now comes the moment that broke the calm forever. Suppose we simply want to know which slit the electron actually went through. A reasonable question. So we place a detector at the openings, a small instrument that registers the electron as it passes. We change nothing else. We only watch the doorway. The interference pattern vanishes. The bright and dark bands collapse into two plane clusters, one behind each slit. Exactly what you'd expect from ordinary little pellets fired through two holes. The wave behavior is gone. The moment we obtain information about which path the electron took, it stops being a wave of possibilities and commits to being a particle with a definite history. Stop looking, and the interference returns. Look again, and it disappears. The universe seems to behave one way when the question is asked, and another way when it is not. This is the heart of the mystery, and it is precisely here that language becomes dangerous. In physics, the word observation does not mean anyone paying attention. It means an interaction, a measurement. Any process in which the quantum system becomes physically entangled with something larger. A detector, a stray photon, a single molecule of air. The electron doesn't respond to being seen. It responds to being touched by the world in a way that records where it was. A machine, sealed in a dark box with no one anywhere near it, will erase the interference pattern just as thoroughly as a scientist staring at the screen. And that should have settled the matter. It should have made the whole thing ordinary. But it did the opposite, because it left physics with a question it has never been able to answer, and which has a name: the measurement problem. What exactly counts as a measurement? At what point does a foggy cloud of possibilities become a single, solid fact? The wave function, left alone, evolves smoothly and predictably, spreading and flowing like the wave it is. Nothing in that smooth evolution ever forces it to pick one outcome. Yet the instant we measure, one outcome is exactly what we get. The mathematics describes the cloud beautifully. It describes the result beautifully. It says almost nothing about the transition between them, the instant the many becomes one. That gap, small enough to write in a single line of equations, has never been closed. For 100 years, the greatest physicists alive have tried to close it, and instead of converging, they scattered. Some, following Niels Bohr and the school gathered around him in Copenhagen, insisted the question was forbidden. Before measurement, the electron simply has no definite position, and asking what really happens underneath is meaningless. Others, led by Hugh Everett, argued the opposite, that nothing ever collapses, and every possibility genuinely occurs. And a third camp proposed that collapse is a real physical event, striking at random, negligible for a lone particle, but near instant for anything large. 3 answers. They agree on none of the essentials. They cannot even agree on whether there is anything to explain. Yet notice what none of them require. Not one appeals to who is watching. Copenhagen needs a measurement, not a witness. Everett needs no collapse at all. The collapse theories act in empty darkness, whether or not anyone is near. By every serious account, watching is not part of the machinery. And yet the machinery still does something no one can fully explain. Out of a shimmering field of possibilities, reality keeps selecting a single, definite state. It chooses. Again and again, trillions of times a second, everywhere in the universe. So if being watched truly isn't required, why does reality still seem to choose? We ended in a strange place. Reality keeps choosing, and none of the machinery seems to need anyone to watch it choose. That should be the end of the story. But there is one door we walked past without opening, and it is the door most people quietly wonder about. What if the thing doing the choosing is not a detector, not a stray photon, not the environment, but a mind? To see why serious physicists were ever tempted by that idea, follow the logic one step further than we did before. When we place a detector at the slits, we say a measurement has occurred. But a detector is not a magic object. It is itself made of atoms, trillions of them, each one governed by the same rules as the electron it is trying to catch. So, by the theory's own logic, the detector shouldn't collapse anything. It should simply join the electron in that shimmering cloud of possibilities, becoming a slightly larger cloud. Now the detector, too, exists in a blur of this happened and that happened. So we look at the detector's readout. But our eye is also made of atoms. It joins the cloud. The signal travels up the optic nerve, also atoms, into the brain, also atoms. At every stage, the fog should only grow larger, swallowing each new system into the superposition rather than resolving it. This is what came to be called the von Neumann chain, after the mathematician who first spelled it out with brutal clarity. In his 1932 masterwork on the foundations of the theory, John von Neumann showed something unsettling. The mathematics never tells you where the chain ends. You can place the dividing line, the cut, between the quantum haze and the single definite fact almost anywhere you like, and the equations come out the same. The theory is silent about the one thing we most want to know. Where does the blur become a world? Von Neumann noticed that the chain has exactly one link that never seems to fall into superposition: your own awareness. Whatever else is uncertain, you never experience yourself as smeared across two outcomes. You always find a single, definite reality. And so, a small number of the 20th century's sharpest minds took the boldest step imaginable. If the chain has to stop somewhere, and if the last link is awareness, then perhaps awareness is where it stops. Perhaps the act of a conscious being perceiving the result is what finally forces the universe to pick. The physicist most associated with this idea framed it as a puzzle. Imagine a colleague sealed in a laboratory, performing the measurement. To that colleague inside, the outcome is settled the instant they see it. But to you, waiting outside, The entire lab, colleague included, is one enormous quantum system, still hovering between possibilities until you open the door and ask. Two people, two irreconcilable accounts of when reality became real. The only way to break the tie, he argued, was to grant awareness a power nothing else in physics possesses, the power to reach into the equations and force a single outcome into being. It was an extraordinary proposal. For a brief moment, consciousness was not a spectator of the physical world. It was its author. And here the documentary must slow down, because this is where wonder and rigor pull hardest against each other. Because the moment you make awareness the hinge of reality, you run into a problem that no laboratory has ever cracked. We do not know what consciousness is. We can say a great deal about the brain. We can watch which regions light up when you see the color red, trace the electrical storms that accompany a decision, even predict some choices before a person feels they've made them. But every one of those achievements describes the machinery of the mind, the processing, the reactions, the behavior. None of them touches the deeper riddle, why any of that processing should be felt from the inside at all. Why there is something it is like to taste salt or to see that red, rather than mere data moving through circuitry in the dark. The philosopher who named this the hard problem of consciousness drew a line between the questions we know how to attack and the one we don't even know how to begin. We can explain what the brain does. We cannot yet explain why doing it should feel like anything. So the proposal asked us to build the foundations of physical reality on the one thing science understands least. And within a generation, that proposal quietly collapsed, not from an experiment, but from its own weight. The criticisms came fast, and they were hard to answer. First, the idea flirts with a lonely kind of madness. If only my awareness collapses reality, how do I know yours does too? The view drifts toward solipsism, the notion that only one mind truly exists, a conclusion almost no one is willing to accept. Second, it is very difficult to test. What experiment could ever distinguish a universe where consciousness collapses the wave function from one where it doesn't? And third, most damning of all, consciousness appears nowhere in the equations. Not once. You can calculate every quantum prediction ever confirmed without writing down a single symbol for a mind. Adding one looks less like physics and more like a wish. Even the man most identified with the idea abandoned it. In his later years, he came to regard his own proposal as untenable, edging too close to that solipsistic trap, and he was moved, in part, by new work showing how the environment alone could wash the quantum fog away without any observer at all. The view that consciousness causes the collapse is now largely discarded by modern physicists, and its afterlife has mostly been in mysticism rather than mainstream science. As one physicist witheringly put it, are we really to believe the universe hung suspended, waiting to become real until some system sufficiently qualified, perhaps one holding a doctorate, finally arrived to observe it? And yet, the deeper question the proposal raised refuses to die, because science has never stopped trying to catch consciousness in the act. Two great research programs now dominate the field, and they could hardly be more different. One holds that awareness arises when the brain broadcasts information widely, when a signal, having crossed some threshold, is flung across a global network and made available to the whole system at once. The other proposes almost the opposite emphasis, that consciousness is a measure of how tightly information is woven together, how irreducibly integrated a system is, captured by a single quantity its architects simply call phi. More integration, more experience. A system with no integration, no matter how clever, feels nothing. For years, these two pictures accumulated evidence side by side without ever being forced to fight. Then, recently, their leading proponents did something rare in science. They agreed in advance to a duel. In a sprawling, pre-registered collaboration, hundreds of volunteers had their brains scanned while the two theories' sharpest predictions were tested against each other. The outcomes locked in before the data came back. Published in 2025, the results did not crown a winner. They favored some of the first theory's claims about where in the brain conscious content lives, while undercutting the second's insistence that the front of the brain must be involved, and left both theories standing, wounded and unconfirmed. Our two best scientific accounts of consciousness cannot yet agree on where in your own skull the experience of being you is happening. Sit with the strangeness of that. We split the atom. We photographed a black hole. We can predict the behavior of matter to 12 decimal places, and we still cannot say with confidence what it is that is reading this sentence, or where inside you it lives. Now hold that uncertainty up against the proposal we just watched fail. Every version of the consciousness collapse idea shared one hidden assumption, the same assumption science has made since its birth: that matter comes first. That the universe is fundamentally physical and mind is a late arrival, a flicker that emerges once matter grows complicated enough to fold back on itself. All the debate was over whether that flicker could reach back and touch the physics that produced it. But there is another way to turn the picture, one that has quietly haunted philosophy for centuries, and that the failures of the collapse idea don't so much refute as leave standing in the shadows. What if we have the order backwards? What if awareness is not the last thing the universe produces, but the first thing it presupposes? What if matter does not give rise to mind, but mind is the ground in which matter appears? We left the last chapter with a quiet, vertiginous possibility that mind might not be the universe's final product, but its hidden foundation. It's a beautiful idea. And there is exactly one fact that seems to break it apart completely. The universe is old. Almost unthinkably old. And for nearly all of that time, there was no one here. So let us do the one thing that turns philosophy into something you can feel in your stomach. Let us rewind. Not by centuries, not by millions of years. Let us run the whole thing backward, all the way to the beginning, and then watch it unfold forward, and count at every step how many eyes were open to see it. In the beginning, there is no sky. There are no stars to make a sky. The universe is a dark expanse filled only with gas, mostly hydrogen and helium, but even that comes late. Earlier still, it is too hot for atoms to exist at all. Matter is torn into a glowing plasma of bare nuclei and free electrons, and light itself cannot travel. It ricochets endlessly off the charged fog, trapped, unable to cross even the smallest distance. The universe is luminous and blind at the same time, radiant and utterly opaque. Then it cools, And after roughly 380,000 years, a threshold is crossed. Electrons slow enough to be captured by nuclei, and the first neutral atoms form. In that instant, the fog lifts. Light, for the first time in the history of everything, is free to fly. That ancient light is still traveling now. We can detect it, a faint hum of radiation reaching us from every direction in the sky. The oldest thing any instrument has ever recorded. It is a photograph of the universe as an infant, taken before there was anything that could be called a thing. And then, darkness. Real darkness. The atoms drift, cooling, formless. Astronomers call this stretch the cosmic dark ages, and it deserves the name. There are no stars, no galaxies, no light being made anywhere. Just hydrogen and helium, finning and spreading in the black for tens of millions of years, gathering with agonizing slowness under the faint pull of their own gravity. Until, at last, the first fire. Somewhere in that dark, a knot of gas grows dense enough, hot enough to ignite. The first star switches on. Then another. Then thousands, then millions, the moment astronomers call cosmic dawn, when the universe finally lights its own lamps. These first stars are monstrous, brilliant, short-lived, and in their cores they perform the alchemy that makes everything else possible. They forge the first heavy elements, carbon, oxygen, iron, out of the primordial hydrogen. When they die, they scatter that enrichment across space, seeding the gas from which the next generation will form. Every atom heavier than helium in your body was cooked inside a star that lived and died before the Earth existed. Here, the story takes a turn that even the experts did not expect. When we finally built a telescope powerful enough to look back into that first billion years, we assumed we'd find faint, small, fumbling beginnings. Instead, we found monsters. Galaxies have been discovered during cosmic dawn, roughly 13.5 billion years ago, far exceeding what theory predicted. Not only far more distant than anything seen before, but surprisingly bright and massive. So much so that almost every model of galaxy formation struggles to explain them. The current record holders formed only a few 100 million years after the beginning, in a universe that had barely had time to make them. The cosmos was assembling grand structures long before anyone was around to admire them, and building them faster than we thought the laws allowed. The universe grinds on. Galaxies spin up. Stars are born and die in vast, silent cycles. 9 billion years pass this way. 9 billion. Before a modest yellow star flickers to life in the suburbs of one ordinary galaxy, wrapped in a disk of debris that slowly clumps into worlds. One of those worlds is ours. It forms about 4.5 billion years ago, and it is still not alive. Life, the very first faint stirring of it, single cells in a warm, dark sea, appears only around 3.5 to 4 billion years ago. And anything you might reasonably call a mind, anything capable of noticing, of asking a question, arrives only in the final thin sliver of the whole story. If you compressed the entire history of the universe into a single year, everything we would call an observer shows up in the last few hours of the last day. Now hold that timeline in your hand and lay the mystery of the last 2 chapters across it. If reality only becomes definite when it is measured, and if, as some were tempted to believe, that measurement requires an aware mind, then for 13 billion years, there was no one to do it. No eye opened. No question asked. And yet stars burned, elements were forged, galaxies turned. The specific atoms that would one day become your brain were assembled in stellar furnaces billions of years before a single brain existed to be assembled from them. How can the process that built the observer have waited on the observer to make it real? The idea seems to devour itself. It cannot be that the entire cosmos hung suspended in a fog of maybe, patiently unrealized, holding its breath through billions of years of apparent history, only to snap into definiteness the moment some warm, wet creature blinked awake and looked up. That is not a universe. That is a stage set waiting for its audience. And nothing in physics suggests reality is so needy. So how do physicists escape the trap? There are several ways out, and it is worth laying them side by side, calmly, because each one leads somewhere different. The first, and the plainest, is simply this: nobody needed to. The whole paradox rests on smuggling a conscious watcher into a place it was never required. Strip that assumption away, and the problem evaporates. The universe was under no obligation to be witnessed. The second is subtler. Perhaps the cosmos was measuring itself the entire time. Every collision of particles, every photon absorbed by a grain of dust, every interaction between one piece of matter and another, each of these can play the role of a measurement in the physicist's bloodless sense of the word. And the early universe was nothing but interactions, ceaseless, everywhere, at unimaginable density. In this view, reality never needed a spectator because it was drowning in measurement from its very first instant. The world was resolving itself moment by moment without a single mind in it. The third possibility bites the bullet in the other direction. What if reality did remain genuinely undecided, a vast, unbroken web of possibility, and only appears sharp and singular from the inside to creatures embedded within it? On this reading, definiteness is not a property the universe has, but a perspective it is seen from. The fourth is stranger and older, and it circles back toward the idea we thought we had abandoned. What if the universe is, in some sense, its own witness? A single, closed system containing everything with nothing outside it, and therefore its own and only observer, forever watching itself unfold. And then there is the oldest answer of all, the one whispered long before any of these words had scientific meaning, that there was, in fact, an observer present at the beginning, one that needed no eye, no brain, no birth, and no end. An awareness that did not wait for the first star, because it was already there when the first star lit. We are not ready to weigh that last one yet. It deserves its own reckoning. But notice that the timeline hasn't ruled it out. It has only sharpened the question that makes such an idea thinkable in the first place. Because here is where all 5 roads meet, and where this chapter has to leave you. For 13 billion years, the universe existed. It burned, it turned, it built. Whether or not anyone was there to know it. Or did it? Can existence exist without being known? We ended with a question that sounds like it belongs to physics, but is far older than any equation. Can existence exist without being known? And here is the strange thing. For most of history, we already had an answer. It is one of the strangest patterns in intellectual history. Civilizations separated by oceans, by languages, by centuries. People who never traded a word or a map with one another, and who, when they turned to the deepest question they could ask, arrived at remarkably similar intuitions. Not identical beliefs, not identical gods. Their stories differed wildly in almost every detail. But underneath the differences ran the same quiet possibility: that reality is never truly alone. That behind every changing, fleeting, perishable thing, there exists an awareness that does not change. That the world is, and always has been, held in the gaze of something that was watching before we arrived, and will be watching long after we are gone. They arrived at this idea again and again by roads that never crossed. And in this chapter, we walk a few of those roads. But before we take a single step, we must be honest about where we are going, because honesty is the whole point. Nothing that follows is predicted by the equations. Nothing that follows can be measured, tested, or confirmed. We are leaving science and entering philosophy and theology, humanity's older and in some ways braver attempts to answer the very question physics blundered into by accident. Keep that boundary clearly in mind. What comes next is not a discovery. It is a possibility. Begin in the West, with a bishop and a tree. In the 1700s, the philosopher George Berkeley proposed something that sounds at first like a child's riddle and turns out to be nearly impossible to refute. To exist, he argued, is to be perceived. At first, it sounds absurd, until you realize that everything you have ever known about the universe has arrived through perception. Every color, every sound, every solid surface you have ever trusted came to you as an experience in a mind. A thing's reality, Berkeley insisted, is not some hidden substance lurking behind that experience. The reality simply is the experience. Which raises the obvious, needling question that generations of students have thrown back at him. Does the tree in the empty courtyard vanish when no one is looking at it? Berkeley's answer was audacious, and it is the direct ancestor of everything this documentary is asking. No, the tree does not vanish, because it is never truly unperceived. There is always one observer present, an infinite mind that perceives all things, at all times, in all places, and by that ceaseless perception holds the entire world steadily in being. The reason reality doesn't flicker out of existence the moment we turn away is that we were never the ones keeping it here. Remove every human eye from the universe, and not a single leaf would be lost, because the watching never stops. Now travel east and start not with a doctrine, but with something you can do right now. Imagine watching your own thoughts. A memory surfaces, then dissolves. An emotion rises, then fades. A sensation appears, sharpens, and is gone. Your mind is a river, nothing in it holding still for even a moment. And yet, through all of it, something remains. Something notices each change without itself being changed. It was there before the thought, and it is there after. Silent, continuous, unmoved. For thousands of years, the philosophers of India pressed on a single question: what is that witness? They gave it a name, the Sakshi, the witnessing self. And they made a startling claim about it. What you truly are, they said, is not the body, not the racing mind, not the changing stream of thoughts and feelings you usually take yourself to be. What you are is that silent awareness in which all of it appears. The witness is the screen. Your entire life is the film projected upon it. The screen is never scratched by the fire on it, never soaked by the flood. It only ever watches. And in this tradition, that witnessing awareness is not merely personal. At its deepest, the ultimate reality, Brahman, is itself consciousness. Not consciousness as something a brain produces, but awareness as the fundamental ground of everything that is, the single reality of which all apparent things are passing expressions. The witness inside you and the witness beneath the cosmos are, in the end, the same witness. One awareness, never sleeping, never blinking. Turn to the great Abrahamic faiths and you find the same intuition dressed in the language of a personal God, but sharpened to a fine point: omniscience. In these traditions, God knows all things, sees all things, and, crucially, knows them continuously. Nothing anywhere is unobserved. Not a sparrow falls to the ground unseen. And this is more than a claim about knowledge. In classical theology, it is a claim about existence itself. Creation is not a single event in the distant past, a switch flipped once and left to run. It is held in being and every instant by the ongoing attention of its creator. Withdraw that attention for even a moment, the theologians said, and everything would simply cease. The universe does not merely need to have been made. It needs, right now, to be sustained, continuously known, continuously upheld. There is a subtler version still. Panentheism, not the claim that God is the universe, but that the universe exists within God, the way a thought exists within a mind, contained by it, known by it, yet not identical to it. It is the same inversion we brushed against earlier when we wondered whether matter might appear within awareness rather than the other way round. Here, that inversion is given a face. And modern philosophy did not abandon this question either. In the 20th century, Alfred North Whitehead built an entire metaphysics, process philosophy, around the idea that reality is not made of inert stuff at all, but of events, moments of experience, woven together. In this picture, God is not a remote engineer standing outside the machine. God is intimately involved, taking in every event as it happens, experiencing the whole unfolding cosmos from the inside, holding each fleeting moment so that nothing that ever occurs is truly lost. Step back and look at these roads together. Berkeley's sustaining perceiver, the Vedantic witness, the omniscient God of Abraham, the encompassing God of panentheism, Whitehead's cosmic experience. Built in different centuries, in different tongues, by people who would have found each other's frameworks strange. And yet they converge, again and again, on a single shape. An awareness that does not depend on being born, that occupies no single place, that never begins and cannot end, and by whose unbroken watching there is a definite world at all. But now we have to let the other voice into the room, because it has been waiting and it is not easily answered. Of course, many thinkers reject every one of these ideas, and their objection is sharp. The remarkable similarities across cultures may tell us far more about the human mind than about the universe. We are storytelling creatures. We are, above all, creatures whose every experience is centered on awareness. We have never known existence from any vantage but the inside of a watching self. So when we face the dark and the unknown, we do the most natural thing in the world. We imagine someone there. Not because someone is there, but because we cannot easily imagine anything else. A child, alone in a room, populates it with presences. Perhaps a species alone in a cosmos does the same. On this view, the fact that so many traditions reached for a cosmic witness is not evidence that one exists. It is evidence of how the mind that reached is built. Similar answers need not point to a shared truth. They may only reveal a shared psychology. And a belief being ancient or comforting or nearly universal has never once made it correct. That objection has real force, and honesty demands we sit with it rather than hurry past. So the boundary returns, and it must be absolute. None of this is what quantum mechanics says. The equations do not contain God. You can practice physics for a lifetime, predict every result to staggering precision, and never once invoke a divine witness. Countless physicists do exactly that. What these traditions offer is not a hypothesis competing with the others. It makes no prediction. It cannot be tested because no experiment could ever distinguish a universe sustained by a timeless observer from one that simply sustains itself. This is not an answer to how the world behaves. Physics handles that alone. It is a proposed answer to the stranger question underneath. Why is there a definite world here to be described at all? Anyone who says the equations prove God is misreading them. Anyone who says they disprove God is asking the mathematics to carry a weight it was never built to bear. And yet, in the 20th century, the most rigorous science humanity has ever produced stumbled entirely by accident into a question: does reality require an observer? That mystics and philosophers had been circling for 3,000 years. The convergence may be coincidence. It may reveal only the recurring patterns of human thought. Or it may point towards something neither physics nor philosophy has yet fully understood. But it is very, very hard to unnotice. Every tradition we have explored begins from a different place, yet somehow they arrive at the same image. An awareness that never began, never sleeps, never looks away. Physics never asked for such an observer. Philosophy never stopped imagining one. Whether those two paths have merely crossed, or have been pointing toward the same mystery all along, remains an open question. If an observer is always required, could the one that was never born be the observer that never blinks? For 4 chapters, we have circled a single word, observer, and asked who or what might be doing the watching. Now we turn the question inside out. Forget for a moment who is looking. Ask instead, what exactly is being looked at? What is the universe actually made of? Because it is possible that we have had the answer wrong from the very beginning, and that the real answer changes everything. Ask almost anyone what the world is built from, and they'll say matter, stuff. tiny solid things, assembled into bigger things. It's the most natural belief in the world. Wrap your knuckles on a table and the table answers back. Hard, present, undeniably there. For most of the history of science, this was bedrock. Reality was made of substance, and everything else was a story we told about the substance. But push down, past the table, past the molecules, past the atoms, down to the smallest level we can describe, and the solid stuff quietly disappears. What you find at the bottom is not a miniature pebble. It is the wave function. That spread of possibilities we met at the very start of this journey. And here is the thing almost no one stops to notice. A wave function is not a substance. You cannot hold it, weigh it, or point to where it sits. It is a ledger, a precise accounting of what might happen and how likely each outcome is. It is, in the most literal sense, information. That realization crept up on physics slowly and then all at once. If the most fundamental description of anything is a description of information, of probabilities, of possible answers, then perhaps information is not merely how we describe reality from the outside. Perhaps information is what reality is. An entire field grew up around this idea, quantum information theory. It stopped asking what particles are made of and started asking what they can know and store and transmit. The humble bit, the yes or no, the 0 or 1, the smallest possible unit of a difference, was joined by its stranger quantum cousin, the qubit, which can hold yes and no in suspension at once. And as physicists rewrote the quantum world in the language of information, they discovered something almost eerie. Nature guards its information with iron rules. Quantum information cannot be perfectly copied. It cannot be truly erased from existence. Push it into the most destructive object we know of, a black hole, and physicists now believe even that cannot annihilate it. The universe, it seems, keeps its books with a fanatic's care. Nothing is ever fully lost. The physicist who saw where all this was heading, decades ahead of everyone, was John Archibald Wheeler, the same man who gave the black hole its name. Late in his life, he distilled the whole vision into 3 words that still ring like a bell across physics. It from bit. Wheeler never claimed to have solved the mystery. He claimed only that every attempt to understand reality seemed to lead back again and again to information. His meaning was radical. Every it, every particle, every field, every force, every object you have ever touched derives its very existence in the end from bits, from answers to yes or no questions posed to the world. Reality, Wheeler suggested, does not bottom out in matter at all. It bottoms out in information, in the answers nature gives when it is asked. Strip away the substance and what remains underneath is not smaller substance. It is a pattern, a code, a vast, self-consistent web of answers. And then physics found something that made Wheeler look less like a dreamer and more like a prophet. It began with black holes. When physicists worked out how much information a black hole can contain, they expected the answer to scale with its volume. The bigger the box, the more you can cram inside it. That is how everything in ordinary life works. But that is not what the mathematics said. The maximum information you can pack into any region of space turns out to depend not on its volume, but on its surface area, on the size of the boundary around it, not the space within. It was as though the true storage of a chunk of the universe lived on its outer skin. That single strange fact grew into one of the boldest ideas in modern physics, the holographic principle. The suggestion is that the three-dimensional world we move through, with its depth, its distance, its solidity, may be something like a projection. That everything happening inside a volume of space could be fully encoded as information on a lower dimensional boundary surrounding it. A hologram is a flat sheet that, lit correctly, throws up a full three-dimensional image. The holographic principle whispers that the universe might work the same way, that depth itself could be a kind of encoded illusion, and the real accounting is happening on a surface we cannot see. It is important to hold this loosely. The holographic principle remains a powerful theoretical framework, not an experimentally confirmed description of our universe. And the frontier goes further still, into territory that is genuinely unsettled, still being fought over in the journals, but breathtaking if it holds. A large body of recent work suggests that space-time itself, distance, geometry, the very fabric general relativity describes, may not be fundamental at all. It may be woven out of quantum entanglement, with space and time springing up from the entanglement of tiny bits of information. Tighten the entanglement between two regions and they are near each other. Loosen it and they drift apart. Cut it entirely and the space between them, on this view, simply ceases to be. Pull out the entanglement and space-time comes unstitched, like fabric losing its thread. Let that settle and hold it loosely, because it is not yet proven. It is a frontier, not a verdict. But if it is right, then space and time are not the stage on which the universe performs. They are the performance. They are what a deeper layer of pure information looks like when there is enough of it entangled in the right way. The way temperature and pressure emerge from the blind jostling of countless invisible atoms. Underneath the stage, there is no stage. There is only information relating to itself. It is worth pausing to appreciate how extraordinary this shift has been. For 2,000 years, philosophers argued over whether reality was made of earth, water, fire, atoms, fields, or energy. Every answer named a substance, some ultimate stuff the world was carved from. Few of them ever imagined that the deepest answer might not be a substance at all, but a relationship, not a thing, a pattern. And that is exactly where the wonder turns, once more, into a question physics cannot fully answer on its own. Because information is a strange kind of thing, if it is a thing at all. Everywhere else in our experience, information needs somewhere to live. Words need a page, music needs a groove or a file, a memory needs a brain. Information always seems to demand a medium, a substrate, a place where the pattern is held. So if the universe is, at bottom, information, where is it written? What is the page beneath the page? What holds the code when the code is everything? Many physicists would stop right here. For them, information does not need a reader any more than gravity needs an audience. Information in modern physics is often treated as an objective property of the world itself. A spin can encode information whether or not anyone measures it. A black hole can preserve information whether or not anyone ever discovers how. In this view, information is not knowledge. It is structure, relationship, correlation. The bare fact that one part of the universe is lined up with another. The universe need not be understood in order to exist. It need only obey its own laws, quietly, indifferently, forever. On this reading, asking who holds the information is like asking who holds the number 7. No one does. It simply is. And yet, that answer leaves another mystery untouched. This is where science and philosophy begin to use the same word in two different ways. In physics, information usually means measurable physical states and correlations, something out there, whether or not a mind is present. In ordinary language, information usually implies meaning to someone, a message, a signal that lands somewhere and matters. Whether those two ideas are ultimately the same thing or only share a name by accident remains an open philosophical question. Physics has never had to settle it, because physics has never needed the second meaning to make its predictions work. But the question does not disappear just because the equations can ignore it. Every scientific revolution has quietly removed one more layer of certainty. We lost the idea that the Earth was the center of things. We lost the idea that matter was solid. We lost the idea that space and time were absolute and unchanging. Each time something we were sure was bedrock turned out to be a story. And now we may be circling something even deeper, the last quiet assumption almost no one thought to question. The idea that information exists entirely independently of meaning. That the pattern and the reading of the pattern are two separate things. If that assumption falls too, if awareness turns out to be woven into the ground floor of reality rather than added at the top, then the whole picture inverts. The universe did not accidentally stumble into consciousness after 13 billion years of blind machinery. Consciousness was there in the foundations from the start, not as a supernatural addition, not as magic, but as one of the deepest ingredients of what is. That possibility remains speculative, unproven, and maybe unprovable. Yet it is difficult, standing here, not to notice where the road has led us. Perhaps awareness is not perched at the top of the ladder at all. Perhaps it belongs at the bottom, more fundamental than space itself, more fundamental than time. And perhaps the pattern was never waiting to be read. Perhaps the reading and the pattern were never two things at all. We have traveled a long way toward wonder. Minds that might shape reality. A witness that never blinks. A universe made of information that seems to lean toward a knower. 5 chapters, each one raising the stakes. So now, in fairness, and fairness is the whole soul of science, we must hand the floor to the people who believe every step of that journey took a wrong turn. And we should be honest from the outset. They hold the strongest hand at the table. This is the chapter where the romance meets cold water. And the cold water turns out to be some of the finest physics ever done. The Skeptics case begins by going back to the word that started all of this: observation. The entire mystery rested on the intuition that something special, something almost magical, happens at the moment a measurement is made. That the universe somehow behaves differently when it is watched. But what if there is nothing magical about it at all? What if measurement is simply an ordinary physical process, one we can now describe in complete, unmysterious detail? That process has a name. It is called decoherence, and it is the quiet demolition of the entire paradox. Here is the idea. In the pristine thought experiments, we always imagine a particle alone, drifting in its delicate haze of possibility, undisturbed. But in the real universe, nothing is ever alone. A particle is ceaselessly bombarded by stray photons, by air molecules, by the faint thermal glow radiating from every warm object nearby, by the cosmic background itself. And the instant it so much as brushes against any of them, something decisive happens. It becomes entangled with them. Its fragile wave nature no longer belongs to it alone. It bleeds outward, spreading into the countless uncontrollable degrees of freedom of the surrounding world. And once that information has leaked into the environment, once the world has, in effect, taken note of where the particle is, the interference pattern, that unmistakable fingerprint of quantum possibility, is washed away. Not erased by a mind, erased by the environment, automatically, blindly, in an instant. And now comes the number that ends the debate for most physicists. The bigger the object, the faster this happens, and not gradually, but catastrophically fast. A single dust grain floating in ordinary air loses its quantum coherence in a fraction of a second, so small, the mind cannot picture it. A measuring device, a cat, a human being. For objects like these, decoherence is effectively instantaneous, complete before any conscious creature could even begin to notice. This is the real reason you have never seen a coffee cup in two places at once, never caught a cat suspended between life and death. It is not because someone is watching. It is because a large object cannot avoid entangling with its surroundings for even the briefest instant. The world is measuring itself, everywhere, trillions upon trillions of times each second, with no observer, no eye, and no awareness anywhere in the process. Look at what that does to the mystery. The measurement we thought required a special, privileged observer turns out to be the most common event in the universe, a blind, automatic, physical fact. And so the tempting idea from earlier in our journey that a mind is needed to make reality definite is not merely philosophically fragile, which we already saw. It is unnecessary. There is now a purely physical account of why the quantum fog resolves into the solid world we live in, and that account contains no soul, no God, and no consciousness. It contains photons and air molecules. That is all. But here, and this is where a lesser documentary would cheat, and where scientific honesty demands we do not, the story is not quite over. Because decoherence, for all its power, does not actually finish the job. And the physicists who understand it best are the first to say so. Decoherence explains beautifully why we never see a superposition, why the world always looks classical and definite. But it does not explain why in any single run of the experiment you get this particular outcome rather than the other one. Think of the cat. Decoherence takes the ghostly blend of alive and dead and separates it cleanly into two distinct, non-interfering possibilities, each fully formed. What it never does, on its own, is tell you which one you will find when you open the box. That final step, the leap from a menu of separated possibilities to the single actuality you actually experience, has a name among specialists: the problem of outcomes. And it remains genuinely, stubbornly unsolved. When quantum physicists have been surveyed on whether the measurement problem is settled, no consensus emerges at all. The experts scatter across every possible answer. So decoherence is a giant stride toward the exit. It is not the exit itself. There is one interpretation that responds to this gap in the boldest way imaginable, by insisting there is no gap, because nothing is ever selected. If decoherence splits the world into cleanly separated branches, a living cat branch and a dead cat branch, then why assume the universe reaches in and deletes one of them? Perhaps both simply persist. Perhaps reality contains both outcomes, side by side, forever, and what you call you is riding along just one of the branches, entirely unaware of the others. This is the descendant of the many worlds idea we met at the very beginning, and notice its great advantage here. It needs no collapse, no chosen moment, and therefore no observer to cause anything whatsoever. Strip away that loaded word. Watch the environment do the measuring. Let decoherence dissolve the fog, and the mathematics run its flawless course, and the great paradox quietly evaporates. There is no ghost in the machine. There is only the machine, vast, indifferent, and endlessly recording itself, with or without anyone there to care. It is a formidable case. It may well be the correct one. Any honest telling of this story has to grant that the burden of proof sits squarely on wonder, and that the skeptic carries far less weight to lift. And yet, notice before we move on what even this triumphant account has quietly left standing in the corner of the room. Decoherence told us why the world looks definite. Many worlds told us we needn't agonize over which outcome is real. But neither one has told us why there is a definite experience at all. Why you open the box and meet one single cat. Why there is one particular world that you actually find yourself inside, rather than a bookkeeping abstraction spread across countless branches. The hardest form of the question didn't get answered. It slipped through the net while we were admiring the size of the catch. And that raises a suspicion, a strange, deflating, liberating suspicion. A century of the most brilliant minds who ever lived has failed to resolve this. What if the reason isn't that the answer is too hard to reach? What if the reason is that the question itself was built wrong from the very beginning? That we have been demanding an answer in a shape that reality was never going to provide. Perhaps the observer isn't the mystery. Perhaps we've been asking the wrong question all along. Sit with that, because it is not a defeat. It is a door. All this time we have been hunting for the observer as though it were a thing, an object hidden somewhere inside reality, waiting to be found. A mind, a machine, a god at the edge of the universe. But every candidate we caught turned out either to be unnecessary or to dissolve the moment we examined it. And maybe that is the clue we kept overlooking. Maybe the observer was never an object within reality at all. Maybe observation is something stranger, a condition of there being a reality in the first place. Follow that thought and you walk straight into the oldest trap in philosophy. Suppose reality really does require an observer to become definite. Fine. But an observer is itself something that exists. So what makes the observer definite? Another observer watching the first? And what makes that one real? Another still? You have started an avalanche that cannot stop. Observer behind observer behind observer. A hall of mirrors receding into infinity. Philosophers call it an infinite regress, and it is fatal to any theory that tries to explain existence by pointing to yet another existing thing. every answer just relocates the question one step back and asks it again. There is only one way the regress can ever end. Not with a final observer being watched by some further observer, but with something that observes itself. Something that is, at once, the seer and the seen. And here is the quietly astonishing fact. We already know of exactly one thing in all the universe that does this. You. Right now. Awareness is the single phenomenon that can turn back on itself, that can be conscious of being conscious, that can hold itself as its own object without needing anything outside it. Self-awareness is the one place in the entire structure where the mirror faces the mirror and the regress finally closes. Wherever the chain of observation was going to stop, it could only ever stop there, in something aware of itself. Which forces a question that would have sounded absurd in any other century, but no longer does. You are made of atoms. Those atoms were forged inside ancient stars, scattered across space, gathered into a world, and assembled over unthinkable stretches of time into a creature that can look up at the very sky those stars once lit and understand it. Think about what that means, structurally. You are a piece of the universe, and you are aware, which means the universe, through you, has become aware of itself. When you look at a distant galaxy and grasp what it is, that is not a mind observing the cosmos from outside. That is the cosmos opening an eye. For 13 billion years, matter arranged and rearranged itself in the dark. And then, in you, and in every conscious being, it began to know that it exists. So perhaps we have had the picture upside down this whole time. Perhaps we are not observers who happened to appear in the universe. Perhaps we are the universe's own act of observation, local, temporary, fragile expressions of something trying everywhere and always to witness itself. Not separate watchers peering at a world, but the world's own awareness, briefly concentrated into 10 billion warm points of view. If that is true, the observer was never missing from the equations. It was never a ghost added from outside. It was the inside of the thing all along, looking out. And if you allow that, then the most ancient idea in this entire documentary stops sounding like superstition and starts sounding like a hypothesis. Because if awareness is woven into the ground of reality, if the universe is the kind of thing that can wake up, then a timeless, boundless version of that same awareness, one that does not depend on any single brain or any single moment, is no longer a category error. It is simply the question taken to its limit. What would it mean for such an observer to sit outside space and time, not far away, but in a place where far and when have no meaning? What would it mean for existence itself to be, at its root, an act of being known? We cannot answer that. Let us be completely honest one final time. Nothing we have found proves any of this. But notice how far the question has traveled from where it began. We started with a pattern of light on a screen. We are ending at the threshold of the deepest question a mind can form. Can anything exist at all, independently of being observed? And beneath even that, the question that has no flaw beneath it, the one Leibniz asked 3 centuries ago and no one has ever answered. Why is there something rather than nothing? Why is there a universe here to be witnessed rather than an eternal, silent, unbroken void, which would have been so much simpler, so much more likely, and would have required no explanation at all. We do not know. And so, having followed the road to its end, we can do only one honest thing. Lay the possibilities side by side, refuse to choose for you, and let you stand where every thinking person who has ever faced this must finally stand. Alone, with the mystery. The first possibility is the simplest, and it may well be true. Reality is entirely, exhaustively physical. Consciousness is not fundamental to anything. It is a remarkable but ordinary product of the brain, an intricate pattern of matter that switches off completely when the matter stops. The universe existed for billions of years without a flicker of awareness and got along perfectly well. There is no cosmic witness, no eternal observer, no deeper meaning waiting beneath the mathematics. There is only the vast machine, and we are a fleeting arrangement within it that briefly lit up, asked why, and will one day go dark. It is a stark picture. It is also by far the most economical, and economy is a virtue science has earned the right to trust. The second possibility inverts everything. Consciousness is not produced by matter. Matter emerges within consciousness. Awareness is the fundamental fabric, and the physical world, atoms, stars, space, time, is something that arises inside it, the way a landscape arises inside a dream, without the dream being made of soil and stone. On this view, the universe is, at its deepest level, mental, and we are not machines that somehow generated minds, but minds that dreamed up the appearance of machinery. It sounds mystical, but it solves in a single stroke the one problem the physical picture cannot touch: why there is any experience here at all. The third possibility is the boldest and the oldest. There exists an eternal observer. Not a being among beings, not a force in the equations, not anything an experiment could ever detect or a telescope find. Not required by the mathematics runs fine without it. And yet, perhaps, necessary for a reason the mathematics can never reach, to explain not how reality behaves, but why there is a reality for the equations to describe at all. An awareness that never began, holding existence in being simply by knowing it. The witness that closes the infinite regress not by being watched, but by being the one thing that needs no watcher. 3 answers. 1 universe. And not a single experiment, in principle or in practice, that can tell them apart. This is where physics ends and where you begin. Perhaps the greatest discovery of quantum physics was never that particles behave strangely. It was that the universe, in the end, forced us to ask a question we were certain science had left behind long ago. What does it mean to observe? What is this awareness we carry and cannot explain? Why does reality exist in a form that can be known at all? Why is it lit from within by understanding, rather than sitting forever in the dark, unwitnessed and unaware that it is even there? Whether the final answer is physics or philosophy or God, one strange truth remains, and it will still be waiting for you long after this ends. The deepest mystery in the universe may not be hidden out among the stars. It may not be buried in the equations, or lost in the first instant of time. It may be much closer than that. It may be the awareness reading these words right now. And so we leave you, not with an answer, but with the question that started everything. The one you are now holding entirely on your own. If reality only becomes real once it is known, then what exactly is doing the knowing?